I'm proud of you that you finally gained courage to dive deep into the world of C. I know it looks scary. You heard nightmares about pointers, memory, low-level C stuff and other, but trust me when I say, C is easier to deal with than your ex. Like, actually. Let me explain. We all love C. Yes, even you just don't know it yet, just like you didn't know who your ex was before y'all broke up. We live in a world written by C, your fridge electronics, your washing machine. It's all written in C. So, let's make a bet. I will teach you all you need to know and some more in less than 90 minutes. If I win, you drop like and subscribe, maybe even share it to your friends in need, and if I don't, you are free to judge me in the comments. Now, why should you learn C in the first place? It's a low-level language. It gives you complete power to do whatever you want to do. Seriously, it's used in penetration testing, writing exploits, making malicious codes, writing chips for cars, fridges, washing machines, embedded programming, kernel development, making operating systems, and much more. I can make an entire video about the usages of C, and that's how powerful it is. You are basically living in the world C built, so learning it would help you greatly in mastering the computer world. You can't take over a country if you don't know the language of the people. I know, you are doubting yourself, asking, will I be able to handle this course? Look, if you had any contact with any programming whatsoever, then this is for you. Be it Python, maybe you watched a tutorial of JavaScript or took a glance at Java, maybe even C# and game development. Basically, if you are familiar with the IT world, this course is for you. You don't have to be a professional programmer to follow along. Of course, if you are brand new to the IT world, there will be another course made just for you. Now, let's stop wasting time and let's get to work. First, we need an environment to work in. We will use the one and only lightweight champion of the world, Visual Studio Code. So, let's get into it. Time to become a wizard, my dear viewer. Let's search Visual Studio Code on Google and click on the first link. Now let's click on Download for Windows to download for Windows, or if you have Linux, click on Debian or RPM based on your distribution. Now when we start downloading, let's wait for it to finish and let's go to installation. Installation is pretty straightforward. You just accept the agreement, click on Next, and here you can put in the file path that you would like your installation to be at. This is Start Menu folder, you can keep it default, just click Next, and here I would leave it as default, although you can change the stuff that you like, of course. Let's click Next, and now let's just wait for the install to finish, click on Install, and that's it. Now that we installed Visual Studio Code, we are going to go to the Extensions tab and install a few extensions. First, click on C/C++ extension, which is going to help us by providing us help along the way while we write code and make us write code more efficiently. Just click on the Install button and wait for it to finish. You can also install the second optional extension, which is C or C++ extension pack, which is, as I said, optional. So do it if you want, it's not necessary. Now we need to download the compiler. Just type MinGW on Google and click on the first link. It should be the SourceForge link. If it's not, check the description and just click on the link in the description. Make sure it's SourceForge. Just click on download and wait for it. To install the compiler, just click on the install once you run the application that you downloaded. Here, keep all as default and click on continue. Here I got prompted with an error screen, which basically means that I already have it installed, so I'm going to click on reinstall, but the installation for you should be a pretty straightforward process. It should start immediately. Now, what the compiler is actually. Basically, C is a compiled language, which means each time we run a C program, there is a program called compiler which takes our code and translates it into a language that our CPU and our computer can understand. That's basically what a compiler is. It's taking our code and translating it into machine readable code. Here, make sure you check these two items, so MinGW base and the other one, MinGW GCC, right? I here unmarked, but you should keep it marked. I just did it so I can show you. Now go to the installation in the top left of the screen and click on Apply Changes. Once you click it, it should apply everything and finish installation. To check if the compiler installed correctly, go to the command prompt and just type gcc --version. If you get an output like this, that means it's all good and your compiler is working. Now let's put it into environment variables so our Visual Studio Code can call it every time we run the code. Type path, or you can also type environment and you will get an output of edit the system environment variables. Just click on it and click on the environment variables on the bottom right of the screen. Now click on the path, double click it, and basically we need to find the path of our compiler first and put it into environment variables. For me it's MinGW bin, which should be for you if you did everything by default and correctly. Go to this PC, MinGW, and just copy the path of the MinGW/bin and just paste it into there. I already have it, so just click OK, and that's it. Let's install one and last extension before we start writing code. Now go to Extensions tab again and search Code Runner. Click on Code Runner and make sure you install it. This is basically an extension which is going to let us to, inside the Visual Studio Code, run and compile our C code every time we write it and want to run it. Wait for it to install and let's start. To create our first C file, which is going to be the file where we write the code in, click on top left part of the screen, File, and then click on the new file, and here just type the name of your file, which is by default going to be main.c. It's basically our main file. You can put in wherever you want it. I put it into YouTube course on my desktop folder, right? And just type main.c, all files, create file, and here we got our first C file. Let's not waste any time. We got the boring stuff out of the way. Let's start writing our first C program. Now, first, before writing any C program, we need to include some standard libraries. To do that, we need to include standard input-output header and standard library header. It's basically a set of functions that helps us do the basic stuff like printing, system input, system output, and similar stuff to that. Now we need to define a main function. Main function is where our C program is going to start from. So compiler always looks for the main function and starts the program from there. After that, we need to return 0 or return any number, but it's unwritten rule that we need to return 0. It's basically when the program reaches that line of code, it knows that the main function ended correctly. If the main function returns 0, we didn't have any errors along the way and the program ran perfectly as it should. Now to print something, we need to write printf hello world in this example, and every single line of code in C is ended by a semicolon. If you don't end an instruction with a semicolon, your program will crash, it will not compile. You have to end every single line of code with a semicolon if you want your program to run correctly. It's basically a C way of indentation in Python, for example. In Python you use indentation to make stuff happen, to like separate the different lines of code. Here you use curly brackets to separate a block of codes. So basically everything inside these curly brackets is inside the block of code of main, and main function holds all these instructions, while a semicolon separates different instructions from each other. Now we're going to do to learn about declaring variables and different variable types in C. Basically in Python, you know that, for example, in Python you can just type x is equal 5, but that will not work in C. In C you need to declare a variable manually and its variable type. Now the most basic variable type in C is an integer. Integer, written as int, basically allows you to assign a whole number value to a variable. In this case the variable x. Now the integer holds 4 bytes. Why is that important? Because we have two other variable types called short and long, which are basically like integer, but they hold less or more bytes of value. Basically short can hold smaller numbers, 2 bytes. You will use short whenever you need to work with some small numbers and you want to save up on the memory, for example in embedded programming and stuff like that. On the regular CPU, regular desktop PC, if you're writing any application for the Windows and stuff like that, you will probably not have to use short because int is very good. Long in this case has 8 bytes, right? It's basically integer, just longer integer, and it holds longer numbers. Whenever you need to do some computation with a higher, bigger, greater number, you will use long because it can hold more bytes of data, which means it can hold bigger numbers, bigger values. Now, apart from the whole number representations, we have a float and a double. Now, what are the float and double? They are representing decimal numbers. Basically, a floating point numbers are represented by using float variable type and double variable type. Float variable type is less precise. It holds 4 bytes of value, while double holds 8 bytes of value, and that's what you want to use if you need a very precise decimal number. Now there is also unsigned and signed variable types. Unsigned variable type is basically a type which holds only positive values. So all 4 bytes of this integer are assigned to positive values, while assigned is a regular variable value type, basically variable type. When you type just the regular integer x, it automatically counts it as signed variable. But if you want to be more precise, maybe for reading wise, for other programmers to read, you will use signed, just so you can tell everyone, hey, this gives 2 bytes to positive and 2 bytes to negative values. It's very important because sometimes you don't want to work with negative values, so you will just make an unsigned integer, so you can save up on memory and assign all 4 bytes to positive values, so you don't have to use long unnecessarily, right? Apart from that, you don't have to declare the value of a variable right away. You can first declare a variable with its corresponding variable type and then assign the corresponding value to that variable in some other line of code. Great, now that we got that out of the way, let's see operations on different variables and on the numbers. Now we can multiply, we can do a sum, we can divide, and we can do a modulo of a variable and some other number. Doesn't have to be a variable, it can be a number 10, a number 5, a number 8, it doesn't matter. But for this case, let's show it as x. X modulo 2, basically a remainder of a division of x by 2. So it will give you a remainder. In this case, 5 divided by 2 is equal 4, right? 5 divided by 2 is equal 4, and the remainder is 1. Now, we also have let's say 2 variables, which is going to be x plus favorite number, and you can also do the same with it. You can do a sum of those two, you can minus sign them, basically you can do a multiplication, you can do dividing, you can do modulo, everything you want to do. And whatever you do here, let's say a sum for example, this value of here, it will compute it and it will assign it as a value to 2 variables variable, right, of integer type. Now there is also assignment operators, which are very important, increment and decrement. How do we do that in C? Basically, there is int, for example, we already declared, let's use this favorite number here as an example. If you want to add 3 to our favorite number, you can just type plus equals 3, and now this is first going to add 3 to our favorite number and then assign it. So basically our favorite number will now become 8, 5 plus 3. It's same if you wrote favorite number is equal favorite number plus 3. It's the same thing. This is just shorter, more easier to read, clearer. I recommend using this, but this is also great if you want readability and if you want to like stay caveman style, right? Now we also have a favorite number multiplication equals 3 or 2 for this case. Favorite numbers divided equals 2. It's the same concept really. It's basically just you multiplying favorite number by 2 and then assigning that value back into the favorite number. favorite number divided equals 2 just divides that number by 2 and adds it back to favorite number. So it would be 5 times 2 is 10, favorite number is 10. In this case, it's 10 divided by 2, it's 5, it's going to assign it back to favorite number. Now, of course, if we forget about this, okay? In this case, it's going to be 10, and in this case, it's going to be back to 5, okay? Now we can also increment and decrement our variables by doing favorite number plus plus, plus plus favorite number minus minus, and favorite number minus minus favorite number. Basically, this is decrement, and this here is increment. The difference between a plus plus favorite number and a favorite number plus plus, same goes for the minus minus and minus minus favorite number, right? The main difference is that when you write favorite number plus plus divided by 10, for example, it will first divide favorite number. So let's say int z is equal favorite number plus plus divided by 10. It will first divide the favorite number by 10, and then it will increment the favorite number by 1. So in this case, since favorite number is 5, like the latest, okay, it will divide 5 by 10, and then it will increment favorite number, which means that favorite number will become 6. Now, plus plus favorite number is the opposite of that, int z2, let's say something like that, plus plus favorite number divided by 2, for example. This will now first increment the favorite number, and later it will divide it by 2. So in this case, the favorite number will be 6, so 5 plus 1 is going to be 6, and when we divide it by 2, it's because this z2 is going to be 3, while in this case our z will be equal to 2, because the difference is this increments by 1, and then after dividing the favorite number with 2, and this first increments the number by 1, and then it divides it by 2. Decrement works the same way. I don't have to show that to you. And basically this is all the operations, all the variable types that you need to know and that you will most likely use very often. This is very similar, a lot of this type is very similar to other programming languages, like doing a sum of two numbers, doing a modulo. This is all something that you should be already familiar with it. I will not get into it for that case. If this is not familiar to you, or you didn't really understand some terminology and lingo and stuff like that, for that case there is going to be a C programming course for beginners where I will go in detail about everything, like you never heard of anything PC related. That's how in depth I will go. For this case, I just want to teach you how to switch to C very fast and make that bridge between your current programming knowledge and the knowledge of C. Now, I hope you understood this, because this is a very, very, very important part of C. Basically, you will always work with variables. Now, I will show you how to do a system output in C, so basically printing something to console. In this case, we are going to use a printf function, which is showcased here. In this case, we are just printing hello world, and if we want to run our C program, we would have to compile this and run it, but we will do that in a moment. I will show you how to compile and run your first C program. First, let's declare a few variables. Let's declare an integer, let's declare a float, a double, unsigned and signed variable. Let's call this decimal number. Okay, now that we declared a few variables, I'll show you how to print them. Now, of course, if you want to print something, you can just type, for example, integer is equal to, let's say float is equal to, let's say double is equal to, and let's say and let's put it into other printf. Let's say unsigned x is equals to, and signed y is equals to something. Okay, Now, how can we input these different value types, these different variable types inside of our printf function and print that to console? We need to use something called format specifiers, which basically specifies where each variable needs to be printed inside our output string. Let's call them placeholders, because they are holding a place for our variables. Now, to print an integer, you're going to use %d or %e. Basically, let's say %d because it's the most commonly used one. For floats, we need to use %f. So basically, all the placeholders, all the format specifiers are started by using %sign. Now, %f is for floats, and for doubles, we are going to use %long float, lf. It's basically a long float is basically a double. Unsigned x, we are going to use %u, and for signed y, we can just use again %d, but let's use %i for this case. Now, after we did this, we can use we need to specify in the correct order all our variables. So basically it needs to be in a sorted order, so each place of each variable corresponds to the numerical place of these placeholders in the printf function. So basically we need to specify number, and now our compiler knows that this number needs to be put inside of this %d. Basically, that's to tell us our printf function that this number needs to put in place of the first placeholder, which is %d. We need to put decimal number. It shows the printf that it needs to put that inside of the %f, so the second place, right? And precise number. Precise number is third place and is going to be put inside of this long f. So basically %lf, a placeholder or format specifier. For unsigned, it's the same thing. It's basically x and y. Now, why are we using the same for the signed and for the integer? Is because the signed specified like this basically automatically assumes that we are working with a normal integer, because a normal variable type of integer is automatically signed by default. Now, if we want to print a new line, since we don't have a system out print line like we have in Java or in Python, where you automatically have the new line written for you, we need to do a \n. This shows the printf function that it needs to print a new line here. Basically, we're doing a \n, and let's do a \tab. \tab is used to print out a tab to the console. Basically, tab is equal to 4 spaces. That's what we print out to the console, right? Now, in this case, is used to basically escape the characters. So if you put it like this, your entire string, your entire output is going to be malformed. It's not going to work. But if you want to print out, for example, double apostrophes, like in this case, you use an escape character, which is \. Now let's put float inside of apostrophes, just so I can show you this. And to run our first C program, we need to do Control S or go upper left corner, File, and Save. Now, if we save our file, we can go to the upper right corner, click this play button, or click on the arrow next to it and click Run Code. Now that we clicked Run Code, you can see our output integer is equal to 10, float is equal to 1.650000, and double is equal to this. Unsigned x is 10, signed y is -5. That's basically what we told printf to do, and it did that. Now, why do we have multiple zeros here? It's because we didn't specify how many decimal places we need to print. If we put here 0.02, it's going to limit it to only 2 decimal digits. Now let's save this and let's run the code again. And you see, now it's 1.65, it printed as it should. So inside the format specifier, you can say 0.02 and then the variable type of float if you want to specify how many digits, decimal digits, you want it to have. Now that's it for the printf function, basically everything you need to know. I will show you now how to do a system input. To do a system input, let's make some new variable called our favorite number, and let's not assign any value to it at first. We will use a scanf function to assign the value to this favorite number. It's basically a system input function, right? We need to put apostrophes, right? And we need to use these same placeholders, these same format specifiers inside of our scanf function to tell our program what it needs to input. In this case, we need to input an integer, so we are going to use %d. And after that, we are not going to use our favorite number, we need to use ampersand our favorite number. I'm going to get into why are we using ampersand later on when we start doing memory manipulation and pointers, but for now just take to your heart that we need to use ampersand and then our favorite number. Now you will see that whatever we put inside of this input here in the console, we will have it inside as a value for our variable. Let's print that also, printf. Let's put a new line and let's put our favorite number is, and then we put our favorite number. Now let's run this program so I can show you how system input works, but first, before we run it, we need to configure some settings. Go to the lower left corner of your screen, go to settings, and in search settings type code-runner.run, and then see this checkbox here, the first one, run in terminal, you check it. Now that we did that, we can go back to our program and start running our code. You can feel free to close this. We forgot here to put %d, and now let's run our code. We see now in terminal nothing is happening because we still didn't input our value that we need to put into our favorite number. Basically, it waits for user to input something before it continues on running. It's basically waiting now at this line of code. Let's input 11. And we see integer is equal to this. It's basically these two lines of printf function. And the last one, our favorite number, is 11. So that's how basic scanf works. You can do the same for %f. So for the floats, doubles, you just change the format specifier and use the ampersand, and then make sure that the corresponding variable is the same as this type of format specifier here. So the corresponding variable needs to be the same as the %d or %f if the corresponding variable is a float. That's it for the scanf and printf. You will use it very often in the C programming language, especially while practicing. Before we start writing our first if statement in C, let's first make a variable called x, and let's do a system console input inside of our x variable so we can have a nice showcase of our program later on. And now to write an if statement, we need to write if parentheses, and inside of those parentheses we put a condition that needs to be met. In this case we are checking if x is equals to 10. If we put a single equal sign, that will not work because that's an assignment operator, so we need to have double equal signs to check if x is equals to 10. Otherwise 10 is just going to be assigned to x. So double equal sign is to check if something on the left side is equal to something on the right side. Then we use the curly brackets to define a block of code of instructions that our if statement is going to run if this condition is met. And also apart from this, like in this case we are printing x is 10, we also have else if statement inside of C. Basically an else if statement inside of C checks if the second condition is met in case the first if condition is not met. In this case we are checking if x is less or equal 10. If it is, we are printing x is less or equal 10. We can also do that for the greater than or and equal, and it's the same thing. Now we can printf new line, just to make it clearer in the output. And let's check further. We can do if, again, x is less, so that's a new relational operator. These are all the relational operators you can use in C. We can also use x is greater than 10, and we can use else. Else, in this case, if x is not less than 10, so this condition is not met, and x is not greater than 10, then else will run, and it will say x is 10. Let's print out another new line, and I can show you the last relation operator, which is not equal, which is written by exclamation mark and an equal sign. X is not equal 10 if that is correct. So basically, if this condition is met, we are going to print x is not 10. Also, we can print something like f x equals 10, and then put that inside of the brackets, like the parentheses, and put the exclamation mark in front of it, which will negate the entire condition. So this will return 1 or 0. Inside of C, there is no Boolean variable type. Basically, int boolean is equal 1 if it's true, and int boolean 2 is equal 0 if it's false. So basically, inside of C, we just use plain numbers, the caveman style numbers, like 0 for false and 1 for true, and it comes from the binary code, basically the binary number system, where we use 1 when the electric signal is there and 0 when it's not. We basically just represent that as true or false inside of C. And what this exclamation mark, the negation, does, it basically checks this condition. If it's true, it flips it into false, and if it's false, it flips it into true. And we can write printf negated x is equal 10 is not equal. Let's say something like that. This sentence probably makes no sense, but just so we can have something showcased here. Now let's run this code. But first we forgot to put semicolons here. Never forget that. Let's run this code. Run code. And we see scanf, let's put 10. X is 10, x is 10. So basically this first if statement run, and if the first condition is met, it's not going to check the other ones. And the second if statement is run, and since x is not less or greater than 10, it will run printf x is 10, basically the else statement in this case. And also we can check the same thing, but with something less than 10, let's say 9. We say x is less or equal 10 because this condition is not met and this one is. And here we say x is smaller than 10 because the first if condition is met, so nothing after that inside of this block here is going to be ran. We also have that x is not equal 10 because it's 9, right? And we see that this is the same thing because writing this x is not equal 10 and writing not x equal 10 is the same thing. And we'll see negated x is equal 10 is not equal. Our weird sentence, right? Now that's it for the relational operators. Let's go for the logical ones. Let's do logical operators now, but first we will need to make two different variables. First, we are going to call first flag and assign the value of 1 to it. And the second variable is going to be called second flag and assign the value of 0 into it. I know I'm very creative with the names of my variables, don't judge me. Now, when we do that, we can make our first if statement with the logical operators and put first flag into it. Now, why is this? We basically don't have a Boolean variable type in C, as I said in the relational operators part, but we only have zeros and ones. What does that mean? When the condition is met, that returns 1. It returns true. 1 represents true and 0 represents false. If we want to flip the condition, we can just type negation sign. Basically, it will turn 0 into 1 and 1 into 0. So true into false and false into true. That should sound familiar to you from other programming languages. We also have first flag and AND. So this is logical AND. It checks if both conditions are true. So if first flag and a second flag are true, it's going to do something. We also have OR. OR is by double pipe. We basically type double pipes here, and it checks either one of those two conditions or variables needs to be true. Also, we have I showcased already the negation, but we can also do it with straight up conditions. We can check first flag equal 10 and second flag not equal 5. We can basically just put straight up conditions instead of just plain variables, and it will check both sides of the AND sign, the logical AND sign, and check if this condition is met and if this condition is met, and if both of them are met, it's just going to print, for example, both conditions are met. And that's it for the logical variables inside of C. You don't really need anything else than this. This is how they work inside of C. It's very caveman, it's very simple. You don't have booleans, you don't have anything, you just have 0, or basically anything than 0. 0 is false, and anything else than 0 is true. But we will use 1 for true because it's like an unwritten rule. It's how we do it usually. We also have bitwise operators in C, which basically just work on the bits individually instead of working on entire variables and their values. So we are not checking conditions, but we are checking the bits. Basically, what does this mean is if we have 1001 and we have 0110. So let's say x is this and y is this. Now we can check x and y is going to give you only the bits that are on the both sides. In this case, it's going to be 0 because we don't have two ones inside of those two variables. It's 1001 and 0110. So 2 bits of the two variables are not the same. Now we also have the OR operator, which is x or y. It will be 1 1 1 1 because 1 and 0 is 1, 0 and 1 is 1, 0 and 1 is 1, and 1 and 0 is 1. So basically checks if either of 2 bits is 1, it will put 1. Now we also have the x upper arrow y, which basically is XOR, bitwise XOR. It checks if only and exclusively only one of those 2 bits is 1, and it will also give 1 1 1 1 because it's OR. But if we had y to be equal to 1 1 0 1, this is going to be 0 1 0 0, because only in the case when one bit is 1 and the second bit is 0, it's going to output 1. We have a bit negation, so let's negate x, and we're going to have 0 0 1 1 0. We can do the same for y, which is going to be 0 0 1 0. And we have a bit shift, which is for example x shift to the left. This is shifting bits to the left. Let's shift them for one place, and that is going to be in this case 0 0 1 1. Depends how many places you shift it into. While if we shift, for example, into the right, we're going to have 1 1 1 0. So it's just shifting operators for bits. We are shifting by how many places we put here. Bitwise operators you will usually not use in C programming language. You will not encounter them often, but it's very important for you to know them, because after all they are not here for no reason. In C we have only 3 different loops. It's while loop, for loop, and a do while loop, which you will probably never use in your life, but doesn't matter, I have to show it to you anyways, so it's not my fault if you forget about its existence. Let's do while loop first. While, then parentheses. Inside of the parentheses we put the condition which needs to be met. Let's put x less than 10, and we do curly brackets to define a block of code that our while loop needs to use. So basically this defines the block of code of instructions that are going to be run inside of the while loop. Now we can put, for example, x plus plus, the most simple one, and let's print f end of loop here, and we can also print f x is equal to and %t, and we call the x, right? That's the while loop. It's very similar to any other programming language. Basically you have a condition, while this condition is met, the loop is going to run, it's going to iterate, and when the condition is not met, so when x reaches 10 in this case, condition is going to be false, and the while loop will end, and the program will start from the next line of code after the curly brackets. We also have for. In for loop, just like any other programming language, we can define 3 segments of the for loop. They are separated by a semicolons. First is declaration of a variable which we are going to use as an iterator. Int I is equal 1, for example. Second is a condition which needs to be met for the loop to work. I is less than 11, for example. And the third is some instruction that is going to be ran every single iteration of the loop. So every single time this loop iterates, this instruction is going to be met. Basically, let's do I++, and we can here just printf value of I is %d, and we put I. And the do while loop is same as a while loop. You put semicolon at the end, while condition is here, put x is less than 10, and do x++. You have to put curly brackets here, right? So you define a block of instructions that are going to be run every single iteration. And it's basically the same as while loop, but it first does something and then it checks the condition. Let's reset x to 0 here, and let's printf value of x is, and then %d and x. And let's print a new line here real quick. And when we run this, you will see loops are not that original. I see it's basically the same as in every other programming language. Only thing you need to know is the curly brackets. And for the for loop, you can actually not use this at all. You can use x and x++. Like, this is also not important. You can even not use this. You can legit just do this. It doesn't matter. Same goes for this condition in the while loop also. But let's reset this back to the original and let's run our program. Also, we need a semicolon here. Never forget semicolons. And when we run the program, you will see x is 9, value of x is 10. We see here written out everything that we did, but I didn't do it in a new line. If we do it all in a new line like this and run the code now, you will see our while loop 1, 2, 3 up to 10, end of loop, value of I is up to 10 again, and then we see our do while loop. It's basically all the same. So that's it for the loops. They are not that original. Do while loop you will legit, I think, never use there. So, but there you go. You have it. Arrays in C are very similar to arrays in other programming languages, but in C we have to define the variable type of the variables or elements of our array. Now let's make an array first. We need to define a variable type, integer, our array, the name of the array, square brackets, and then equals. Now, if you want to define your array immediately and put all your elements of the array immediately while defining it, basically initializing your array right away, you can put square brackets and then put 1, 2, 3, 4, 5 as elements, for example. And now compiler will immediately know, okay, this array has the length of 5. We see 5 elements here, which means that array has a length of 5. But the important thing is that you can't combine floats and integers and characters and other variable types inside of the array, which is a type of integer. So basically, when you define the variable type of your array, every single element inside of that array has to be of that variable type. So let's keep it as 1, 2, 3, 4, 5. But if we want to define an array without initializing it immediately, we can just define it like this. We put the length of our array, let's say 5, and then we access every single index of it single-handedly, manually, right? And appoint the value to it. So let's say 1, our array index of 1 is 2, and we do that for every single element inside of the array. Let's put the length of 3 so I don't have to go all the way to the 5. Now, as you can see in C, we are starting the indexing from 0. 0, 1, 2, 3. Now, if you tried doing something like this wouldn't work because you don't have a third index in your array. It's only the length of 3. If you want to check the length of an array, you can printf. You don't have to printf, I'll just show it so we can see the output. You do the size of our array. Now, when we run this program, you will see that length of an array is 12. Why 12? Because it has 3 elements, it's the length of 3, and every single of those elements is a type of integer, and since integer is 4 bytes, that's 4 times 3, so length is 12 bytes. We can even put bytes here if you want to make it more precise. So the length of our array is 12 bytes. That's how much this array holds in memory. And it's very important in C to know how much bytes and how does memory work. Not even in C, generally in programming, in computer engineering, in computer science, you always want to have at least some vague understanding of how much memory something takes up. If you want to make a multidimensional array, so let's say a matrix into matrix, and let's say it's 5 by 5, and let's say that we don't want to input every single element manually, but we want to scanf, like in the system input, we want the user to give us the values of each of matrix elements. We are going to use a for loop, the easiest way. For int e equals 0, I is less than 5, I++, and we do another nested for loop for int j is equal 0, j is less than 5, and j++. And we do scanf %d, and we put it into matrix I, j. Basically, this is how you do it in every other programming language also. I just wanted to show you guys here how it would work in C. This basically makes a two-dimensional array where every single element inside the first dimension holds 5 elements inside of its second dimension. It basically looks something like this. So it's 1, 2, 3, 4, 5, let's say, and then the next element holds 6, 7, 8, 9, 10, and then we go again, and so on, so on. Let's not waste time on that. You should be familiar with how multidimensional arrays work if you did any programming before this, and this course is for you guys. Another very important thing regarding arrays in C is that unlike Python, for example, you can't just do printf and then print the entire array. It doesn't work like that. To print the array in C, basically printing each element of the array, you have to go through a loop, and in each iteration you have to print one element. How would that look like? Let's make a for loop, for example, int I is equals to 0, I is less than 5, I++. I, in this case, is going to be an iterative variable which we are going to use as our index. And we will printf %d, and let's make a space here so it's more readable, and then levels I. So this will go through entire loop and print each element that's found at I index in the array. So when we run this program, you will see that we will get the entire levels array printed out. Give it a moment. 1, 2, 3, 4, 5. If you want to print out a multi-dimensional array, right? You would do the same thing, but you will do for int j. We will make another nested for loop, for example, and then j++. This is in case that, of course, we have something like this, right? And then we have like 1, 2, 3, 4, 5, and then here also, and here also. Actually, let's demonstrate that. We don't have to make it fancy. So if you're printing multidimensional arrays, for each dimension of the array, you have to make one additional nested loop to print out everything. And now we will print out here int I and j, and here let's just put a new line so it's more readable. You will see this is how we print out a multidimensional array, in this case a matrix. And basically this is very important because probably most of you are used to just doing printf levels, for example, and it printing out the entire array by hand, automatically, if you know what I mean. Here in C you have to go through each element of the array and print it individually, and then you will see that your entire array is printed out after those two, in this case two, for loops are done with the execution. So that's how you print out arrays in C, and that's how you do the work with arrays. Basically, everything regarding arrays is based on while and for loops, and do while loops if you prefer it for some reason. Basically, you need to know that arrays in C are usually worked with inside the loops. It's time for characters and strings. Now, I didn't mention characters at the variable part of this course because I thought it's way better for you to learn about characters in C alongside the strings, since strings, as you will see, are an array of characters. Now, to define a character variable, we use keyword char. Char, variable name, and then to point the value to that variable, we put character inside of single apostrophes, and now we have variable which holds the value of a. Char is just another variable type used to hold character values. Now, unique thing about C that you can also see in many other programming languages is that every single character can be represented as its ASCII value. Its ASCII value is a whole number, so for example 65 for A, which is equivalent to a character A. Same like that, you can make integer x to be equals 65, and we can print both of those, and you will see that we will get the same character. Let's print both of those. Let's say character char, double dots, and %c, and character number, and let's do %c again. And you will see now we'll put R grade as first and X as second, and you will see that when you try to print out a character, which is %c, you will get A, but when you try to print a number 65 and put it into a format specifier of %c, you will see that you will also get 65. So let's run this program and see what this magic does. Here we go. Character number and character char. That's it. You see, that's all you need to know about characters. Basically, they can be represented as both the number value and the character value, or character inside of the single apostrophes. Now I'm going to put Ascii table on the screen for you guys so you can see how it looks like and which character is equal to which. But usually when you work with characters, you will just Google the Ascii table and do it like that. Another fun part about characters is that you can increment them by some number and get the next number in the Ascii table. So if we do a++ here in the R grade variable, you will see that 65 is equal A, and then we will get 66, which is equals B, because we incremented this character by 1 and then assigned it to R grade, which means that the value of this is going to be 66, which represents B. Now, if we do +2, for example, we are going to get C. 67 is equals C. Now let's run this printf again, this entire code, and you will see that here inside of our grade we're going to get C printed out, while character number and then %C is going to print out A still. So let's run this code and see what it gives us. Character char is C and character number is A. That's another fun part about characters, and let's go to strings now. String data type in C doesn't exist. Basically, in C they decided, why would we have strings when we can have an array of characters? Great, isn't it? So let me show you how strings work in C. Basically, you just make a character variable type, character variable, called string, for example, rstring, let's name it rstring, and you put square brackets here to represent it as an array. Now, to assign the value to that string, you need to put a double apostrophes, semicolon at the end, of course, and you put something that you want to see. For example, hello dear viewers, I hope you enjoy the course. Now we have the most basic string in C. If you want to print out string, you need to do printf, %C, and then rstring. Another way to define rstring is to implement every single element manually. Basically, you would put curly brackets and you would put every single character. H, E, E, what? L here, of course, don't mind me. L here, O. And at the end, you always have to have the null terminating character. What is the null terminating character? The null terminating character is the character that represents the end of the string in C. So basically, so C can know where the string ends. It will go through this entire string, character by character, and it will know that here is the end of our string. And you will see now, if you try to printf all of that, let's put a new line, let's put %s, and let's just put %s and do second string. It will print out perfectly normal. If you forget this, it will not recognize the end of the string, and it may do some weird stuff with your program, right? So you always want to implement the no terminating character, add it on as the last element, so C programming language can know when where you ended your string. Now we can also access each of the elements of our string by its index, like in other programming languages. Let's do that here also. Third character of our string, and we put our string second index, because it will be L, it's a third character of our string. If we run this program to check our output, you will see, hello dear viewers, I hope you enjoy the course. Hello, third character of our string, and it's empty. Why is it empty? Because we forgot %C here, but if we run it now, you will see it works. We got the L here. Nice. That's the most important part about strings. You have to remember that this no terminating character is there for a reason. It's to determine the end of the string in C. And now I'm going to show you how to get a system input for strings and how to put it back onto the screen. Another way you can put it back onto the screen is to do puts, put s. So put string, and we type our string. Or let's do it for a second string, for example. Second string. It will print out second string, we will show it later. And if you want to get the user input into some string, you first need to make input as string variable, for example, and just define the length. Let's put the length at 1000. We will use the fgets function. Fgets function is safer way of gets function, get s, so get string. And what you need to put into that function is first the buffer, and that's basically a string we are going to put everything in, and that's inputted string. You need to put max count, which is how many characters it can hold, which is basically size of inputted string. And we need a file. Basically not a file, but where are we getting the input from? You will see later on when we do the working with files part of the course that this same fgets function will appear again. For now, you always put standard input as third segment, third parameter of this fgets function. So now we have the user input inside our inputted string, and we can just puts inputted string. And let's run the program. Hello dear viewers, I hope you enjoyed the horse. Hello, because we printed second string, and now when we type here, this is working perfectly. Nice. There we go, it printed it back to us, which means that our program works. And that's how you get user input in form of a string from a console. I will show you some useful string functions which you can use to work with strings in C. Of course, C is not completely caveman built programming language. You have some built-in functions, and to use those built-in functions you will need to include a library. Now we will include library at the end. First let me show you those functions. First one is for finding the length of a string, or how long our string is. You will use the string len, or strlen, our string function, string length function. You type it like this, and that will give you the number, a whole number, an integer of how long our string is. Now we also have a way to concatenate two strings. So basically concatenation is when we put the second string, so second string is getting concatenated onto the first one. You will see what we get when we print it out. To print out a string, of course, you use %s. We also can copy one string into another. Since you can't just replicate two strings, you can't put that string 1 is equal to string 2. It doesn't work like that in C. You have to copy one string into another. For that, let's make a new string. Let's string copy the second string. So this is the destination string, and this is the source string. So basically we are copying from the source, the second argument, into the first argument, into the new string. We then can print out new string, just so I can show you guys that we get the exact same string but on different memory address. Compare two strings with strcmp. Basically this will return 0 if strings are same, returns less than 0 if first string is alphabetically sorted before the second, and if it's sorted after the second it will return more than 0. It's important to know what it returns. If you are doing some if condition, some if statement, and you have a condition where you have to alphabetically sort some strings or something like that inside of an array or a list or something similar, you will use string compare very often. Now also you have many more. For example, you have str which finds a substring. You have string char which finds a character inside of the string. You can search all of those on the internet. You can Google them, like C string functions, and you can see whatever you need. These are just some of the most important ones that you will use on your day-to-day life when coding in C. If you remember from the beginning of this video, we made a main function, which is where our code starts running from when we run the program. And as you can see, we made integer main. So this int here, since you remember in variables it defines the value, the type of value that variable is going to hold. In functions it defines the type of the return value that function is going to return, in this case 0. Since 0 is an integer number, we declare this function as an int main. Parentheses is where we put our parameters of the function, and curly brackets just define the block of code that function is going to run. Now let's make our own function. Integer add two numbers, right? We will need int a and int b, and we will return a plus b. As you can see, inside of these parentheses we put the parameters of the function. Since we will need two numbers provided to the function when we call this function, we will put int a and b so we can do some calculations and return some third number, in this case a plus b. And since the return value is going to be also an integer, we have to declare this entire function as an integer, right? Now let's make int x make equals 5, int y be equal 3, and let's printf x plus y is equal %d, and let's call our function. Add two numbers, a plus x and y. So we provide the number x inside of this parameter, and we provide the number epsilon instead of this parameter, right? 5 and 3. So now this will be 5, this will be 3. When you do this calculation, it will return 8. Let's run this program. And you see x plus y is equal 8. Nice. That's basically how you make functions in C. Now you can also make a float, you can make a double, depends which return type that function is going to have. And if it will not have any return type, so if it doesn't return anything, let's say it just does something. It, for example, changes some things, does something, but the return value is not really interesting to us. We don't need a return value in that function. We're going to make a void. And in that case, the function is not going to return anything. You don't even need to have return here, since it's void, it doesn't return anything. And that's basically how you make functions in C. The scariest part of every single student that ever had to learn C programming is definitely pointers. I know you heard about pointers, you heard the worst stuff about pointers ever. It's not that scary, it's not magic. I will explain it now clearly so you can never have question about pointers again. Really, it's a simple concept that people misunderstand very much. Of course, if you want to really handle pointers like a pro, you will have to practice and practice with them, implement them in your code, and then you will know your pointers very well. First, let me show you something. Let's make an integer x and make it be equal 5. Let's make a variable, okay? Now, we see this x here. Every single variable in our C code has its corresponding memory address. So every single of these variables that we make has some address in memory where it's stored. This value 5 lives in that address. So the house of this value 5, where the 5 lives in, is located at the memory address of x. So the memory address where that x is stored, right? That means we can get that memory address by doing one simple trick. Let me show you. Let's printf %x. Now %x is just a format specifier to print a hexadecimal value. So now we want to print a hexadecimal value of the address so it's easier to read. So we don't get a huge number, of course. And we will put %x instead of just x. If we just put x, we will get this in hexadecimal value, but if we put %x, we're going to get the memory address. What this ampersand does here is it gets the memory address where this x variable lives at. So it basically is like, hey, Google Maps, this is the address, can you get me it? And in this case, this is that address. It's the address of this x. It's basically same like if you know a person and you know where he lives at, and he gives you his address. And whenever you go to that address, you can find that person. In this case, you can find that variable. And to get that address, we use ampersand and then the variable name. Let's run this program so I can show you it. We need to put semicolon here. Let's run the program. And you see here we got the address of our x variable. Now let's make another variable, and let's make that variable point to that address. Like it's, I will explain it in a moment. Let's make a variable int, and then the pointer sign. Basically, this is pointing, or multiplication sign, whatever, asterisk, however you like to call it. Px, why px? Just so we know it's a pointer to x. We can call it pointer to x, okay? And let's assign it a value of the address of x. Now we have a pointer here. This is our very first pointer. This pointer, this is not a regular variable. In this case, this integer is not the type of this variable. It's the type of the variable that it's pointing to. So since this is pointing to the address of an integer variable, this has to be integer also. In this case, integer is the type of the variable that this pointer is pointing to. It's very important to know that. Now, let's get the address using this pointer. Let's printf, and if we just do pointer to x here, since pointer to x is equals to the address of x, you will see that we will get the same address. See, we got the same address here. Now we can get the value that resides in that address very easily by using the asterisk symbol again. Let's do that. Let's do that. %x, and let's use asterisk symbol again, and then pointer to x. Now when you call this pointer to x, you can think of it just like calling a regular variable which just has the value of this address. But when you use this asterisk again, you're looking at this pointer. Okay, this pointer is pointing to the address, and this another asterisk here is going to take that person that lives there, forcefully throw it out of the window and take it home. And we're going to get the value that resides in that address. It's as simple as that. Now let's run this program. You will see that we will get 5 here. Let's run it. You see 5. So basically this pointer points to an address, and now this asterisk goes to the address that this pointer is pointing to and takes whatever is in there and gives it to us. You can even do something like this. Int y is equals to 7 plus and then pointer to x. And you will see now we can printf %d y. Okay? We don't have to use %x here, we can just use the normal. And you will see 12. 7 plus 5 is 12. You can't do it without this, because this will make a sum of an address and a digit, and you will get some big number. You will get an address which is 7 places after our original address. I will show you that. %x. See, this is 14, and when you add 7 to it, we get an address that's 7 places, 7 bytes after that, basically. Imagine a street, and this is like the first house in our street, and then we go 7 houses down and we get this number because each house is 1 byte in our example. Now that's basically what pointers are. They are just a type of variable that are defined that define their variable type based on what they are pointing to. So since we are pointing to an integer variable, we define the pointer as an integer, and it's a type of variable. We just points to some memory address. It points to something else. So it doesn't it doesn't hold a value directly. It just stores a memory address. So it doesn't store 5, but it stores the address in memory where 5 is located. Think of it as a signpost. Instead of holding the actual object, it tells you where to go to find it. That's the scariest part of the C programming, and that's what makes everybody quit C. Please, I hope you're not one of them. I hope I explained this to you very clearly. Now there is some other stuff regarding the pointers I want to show you. You can change the value of the x variable using this pointer. And how do we do that? Let's do that. Let's do, for example, so asterisk pointer to x is equals 25. Okay? What does this do? This pointer goes shows our this address. So this pointer holds this address. We are accessing the value at this address and changing the value at that address to 25. So we literally go to that house on that address and we put some other person in, and now that person lives there. Because we have a pointer to that house, we have basically a variable that holds the address, and now when we try to access the value using this asterisk at that address, we can change the value at that address. Let's print this so I can show you it. And let's print x. So we're printing x now. Remember, we didn't change x nowhere. We just used this pointer to change the value of x. you see x is now 25. It changed from 5 to 25. It's as easy as that. That's all the pointers are. That's how you work with pointers. Remember how we have different variable types. We have integer, we have char, we have double, float. Did you know that in C we have enough freedom that we can make our own structure? We can make a structure which holds different variable types, and therefore we can basically make a new variable type. Let me show you how we can do that. We type struct, student for example, the name of our structure, the name of our new variable type, and this structure can now hold different fields. It can hold some sub variable types. Let me show you that. Let's say for example char name, the length of 50 for example, int age and int id. Now what is a structure in C? A structure in C, you have to end this with a semicolon and put all the fields in between curly brackets. The structure in C is a way to make a collection of different variable types under one name, under one variable type. Let me show you how you can do that. We can now make a variable using this structure. Struct student, new student. Okay? And then we can assign the values of this student using new student dot and then which field we want to fill. Age, let's say 23. Can you do some for me? New student dot id is 1619 for example, and string copy, because we can't just straight up assign a string to this field because it will not work like that, like I explained the strings. String copy new student dot name, and then we will copy into the name, we will copy a string called, let's say, Marcus. Okay, now we can print all of this. Printf student's name, student has a name of %s, age of %d, and let's say his id is %d. And now let's print all of this. First new student dot name, new student dot age, and new student dot id. Okay, that's great. Now we can run this program and see what we get. Student has a name of Marcus, age of 23, and ID is 1619. And as you can see, we did nothing here. We made just one variable, and all these different variables are inside that one structure. That's why structures are so powerful and so useful in computer science and C programming. Now, if you don't want to type this struct here every single time, we can use something called typedef. It's to define our type as a variable type, so we don't have to every single time write struct and declare that it's a structure called student. We can just type typedef struct student, and then at the end you can also put student instead of at the front. It doesn't matter, you can also put it at both of them. And now you just can type student new student, and there you go. You got yourself a new variable type using typedef to define a new type and making a struct. That's great. Let's run this program. And you see the output is the same. We have a new variable type, and we are our own boss. We are the kings of this language. We control whatever we want. It's finally time for the last part of this course. This is it. We came to an end. Let's learn how to write to files, how to read from files, and how to generally work with files in C. Basically, up until now, we always use variables, and we did operations on variables, and that stuff, that information, everything we did, it lasts as long as our program lasts. But what if we want some calculations to last or some stuff to last even after our program? We need to save it into a file, or we need to read something from a file if we need it in our program. Because of that, you need to learn how to work with files so your programs can have a lasting impact. I made a stuff.txt file here in the same folder that my main.c file is in, right? So let's open that file. First, to access a file, we need to declare a pointer to a file. So we type file, let's name it asterisk to declare a pointer, our file, and it shall be equal to, let's say, fopen to open a file, and then we need to specify a path, and we need to specify a mode in which we are going to open that file. Now, for path, you have multiple different options. You can do a relative path. Relative paths always start from the parent folder. So since we are in YouTube course, if we want to access this output folder, for example, we would do /output/ and then stuff.txt. But since this stuff.txt is in our main folder, we can just type stuff.txt because main.c and stuff.txt file are in the same folder. So we don't have to write anything else. You can also use absolute path. For example, let's right click to this and let's copy path. You will see that the absolute path of this is exactly this. Now you have to put double backslashes here, so C can know that those are not escape characters, those are actual backslashes, right? But for our uses right now, we are going to use just stuff.txt. Just so you know that you have multiple different options. You can use a relative path, or you can use the direct absolute path. Also, we need to specify a mode. There is many different modes. There is R to read from a file, so it reads an already existing file and loads in the data from it. You can use W. It opens the file for writing, and if the file doesn't exist, it creates a new one. But if it does exist, the writing starts from the beginning. So everything that's already written in that file that already exists is going to be erased, and you're going to start to write from the beginning. Now we have A, which is append. We are appending to a file. It's opening the already existing file, and it's appending the content onto already existing content in that file. You can also use R+. R+ opens an already existing file for reading and writing, while W+, it opens the file for reading and writing, and if the file exists, its length is getting reduced to 0, and if file doesn't exist, it creates a new file. So basically this is what you use if you want to make a fresh file with some name. And A+, same like R+ and W+, A+ opens the file for reading and writing. Reading starts from the beginning, and writing to the file starts on the end of the file. So we are appending, when we write, we are appending the content onto already existing content, and when we read from the beginning. If the file doesn't exist, it just creates a new one. Now, when we made this file, let's say we make it for reading at the beginning. Let's type into stuff.txt, for example, I like good C courses. This one is good for me. I hope it's good for everybody. This one is good for good people. Just kidding. Let's make something more fun here. Let's say, for example, every monkey has a chance to accidentally write Shakespeare. I am a monkey and I could never write Shakespeare. I think this is pretty fair to have in our file, right? Now let's read this from our file. How would we do that? We would first have to make, for example, a string line, and let's make the length of it 1000, for example, okay? Let's read line by line. To read a line, you type fgets and then you type the buffer. So remember, it's the same as reading an input to the string. So buffer is a line, size of line is the max count or the max amount of data that you can input, and the file is not going to be standard input like in the system input that we did, console input, right? It's going to be the name of our file or the pointer to our file, in this case our file. Okay, now this is going to read from our file, is going to read a maximum of 1000 characters line by line into this, and it will put the data into this line. fgets reads line by line, so whenever it gets to a new line, in this case you see here is a new line, when it gets to the new line it will stop, so it only reads one line. It reads a line until it gets to an enter or to a break or to a new line, right? Now we can put line and see what we got here. Let's run this program. Every monkey has a chance to accidentally write Shakespeare. But let's say we do fgets again. If we do fgets again, we can put line again, right? And look what we get now. We get the both sentences. Why do we get the both sentences? Because fgets has a buffer, and that buffer knows where it stopped. So it knows that it read the first line and that it stopped here. It stopped on the second line. So next time you call fgets on the same pointer to a file, in our case our file, next time you do that, it will start reading from the next part that it hasn't read. It will not read from the beginning, it will read from where it started. Now, you can also read a word by word in the file. How do you do that? You use, let's make a char word, make 100 length, and let's use fscanf. Our file as a pointer to the file, right, is the first argument. The second argument would be %s, so the format which we are reading, and the third will be the buffer where we will store that word, in this case in our variable word. Now if you try to printf word, let's printf %s, new line, just to make it clear, and we type word, you will see that we will read a word. Okay, every monkey has a chance to accidentally write Shakespeare. How does that work? So you see, we here first wrote every. We have every, so it read the first word in our file. It's every. Now it stopped here. Okay, now fgets continues and reads from there, and it writes monkey has a chance to accidentally write Shakespeare. Now fgets stopped here, and next time we call it, we can get I am a monkey and I could never write Shakespeare. See, that's the output that we got. So we can read a word and it always knows where it stopped. It always knows where it stops. So you can put it in a loop, and when you put it in a loop, you can just read 1,000 and 1,000 of lines and do some calculations and operations with them, store them somewhere, store them inside of structures. It's very useful to know that it knows where it stopped, so you can use them in the loops. That means that you don't have to call this function every time, you just put it in a loop and do the operations constantly, and there you go, you just did all your operations on a file using one loop. You read every single line, you did what you had to do with that line, and that's it. Now, you can also read a character, right? Char our character. And let's do fget c and the file of our file, right? Our file. That is going to read a character. So we type our character is equal to fget c, right? And when we run this and print our character, printf c our character. Let's run this. And when we run this, you will see very monkey has a chance to accidentally write Shakespeare. That's it. Let's go. So we can read a character by character. We can read word by word. We can read line by line. We can put that line back onto using puts, right? The line that we stored that line from our text file into. And now it's time for writing to a file. Now to write to a file, I erased everything in this file, and let's write to it. So let's open it in the write mode, And to write to a file, we have a few different functions that we can use, but the main function that we are gonna work with is definitely gonna be fputs. So let's write something to our file, fputs, and then it takes from us the string that we want to put and the file where we want to put it. Let's put it into our file, and let's write every monkey can eventually write Hamlet. Okay? Now let's save this and let's run the program and see what it gives us. No output, but if you look at stuff.txt, every monkey can eventually write Hamlet. Now if we do the fputs 2 times, let's see, also every monkey can code in C, and let's say we are not monkeys, therefore C is easy. And let's save this and run the program. Bam! Every monkey can eventually write Hamlet. Also every monkey can code in C. We are not monkey, and therefore C is easy. That's because we didn't put a new line character at the end of the strings that we want to write to our file. Let's do it again, and you will see it will erase all of this and write it again. Run code. Every monkey can actually write Hamlet. There is everything that we wrote. Now let's open it in append mode, and let's fputs. Every monkey can eventually write Hamlet. Let's say, for example, even though C is scary, I don't fear it. Now let's run this code. Control S to save and run the code. You will see it didn't erase everything, it just appended to it. That's basically how you write to files in C. This is the most often what you will use. So that's it for this file, and that's it for more or less all the tutorials that you had here about C. Also, one important step that you have to do every time you finish working with files is fclose our file. You need to close the file so it doesn't have some stuck buffer that can maybe cause some problems later on, or if it's some more complex program, you always want to close your files after you're done with them. So let's run this. You will see it closed. We appended it again, and that's it for files. That's it. We finally covered all you need to know about C to start coding on your own. I hope you enjoyed the course as much as I did making it. Now I want to give you a few tips first, and that is where to go from here. Practice, practice and practice. I can't emphasize this enough. You can watch all the tutorials in the world. If you don't sit by yourself and use your own hands and brain to write code, you will never learn to write code. So never be lazy. Always practice what you learned. Try making some fun projects, for example, a web server, or maybe something simpler like a simple calculator or a to-do app. Basically, anything that is fun to you. Also, don't be afraid to challenge yourself. Try making something above your level. It might be hard at first, but in the end, it's going to be worth it. I am Philip, and I hope you enjoyed and learned a lot of new stuff. Please feel free to leave your thoughts and questions in the comments below. I'm not going to bite. If you liked the video, make sure to leave a like and subscribe, and I hope I'm going to see you in the next one.